Listen to part of a lecture in an astronomy class.
Now, are you all ready for some twinkle twinkle little star? Great. First of all, what is a star? Well, a star is a massive self-luminous ball of gas, made mostly of hydrogen and helium, that produces light and heat through nuclear fusion reactions. There are zillions of stars in the observable universe. And the nearest star to Earth, as you all know, is the Sun. The majority of stars in the galaxy, including our Sun, are main sequence stars. Main sequence star is a star that is burning hydrogen in its core. This means it fuses hydrogen into helium. And for most of its lifetime, a star will live the majority of its life in this stage of its evolution. There are many other stars that we can see with our naked eyes from Earth at night. And because they appear as small dots of faint light, too dim to activate our light sensors that detect color in our eyes, stars mostly appear white to us. Even though the visible stars can range in color from blue to red. Stars can be categorized into distinct classes, or groups with stellar classification. The classification of stars is based on the star's spectral characteristics, which use a combination of two classification schemes. The Harvard system, which is based on the surface temperature of the star, and the MK system, which depends on the star's luminosity. Stars of different temperatures appear to glow with different colors. Have you ever seen iron or steel turning red when it is heated? It will start to glow red, but as it gets hotter, that red will turn into yellow, and then white, and then eventually, the metal will be glowing blue. In the same way, very hot stars are actually blue. That's why from hot stars to cool, that is, in order of decreasing temperature, the stellar types will be O, B, A, F, G, K and M. Sounds confusing, right? A traditional mnemonic for this sequence is "Oh be a fine girl, kiss me," which I hope you find useful in memorizing the arrangement. So, O and B are extremely hot, bright and massive stars, which are pretty rare. Perhaps, about 1 in 3 million of the main sequence stars in the solar neighborhood will be Class O stars. Class O are bluish-white stars with surface temperatures ranging from 25,000 to 50,000 Kelvin. On the other end of the spectrum, the more common types are M stars, which are cooler and dim. More than 70% of all main sequence stars are M stars. These M stars are red and their surface temperature is about 3000 Kelvin. Now, I want to explain a little bit about the Hertzsprung-Russell diagram, also known as the HR diagram, which is one of the most important tools in classifying stars and understanding stellar evolution. Independently developed in the early 1900s by two astronomers, Ijner Hertzsprung and Henry Norris Russell. This diagram or graph plots the temperature of a star against its absolute luminosity, or magnitude. The horizontal axis of the HR diagram shows the effective temperature of a star. The highest temperature is on the left-hand side, and decreases as it goes to the right. Some HR diagrams include the color of stars, corresponding to the surface temperature on the horizontal axis. I am pretty sure you will be able to plot the blue stars here. Should they be on the right, or the left? Moving on, the luminosity of the stars is plotted on the vertical axis. One careful point to remember is that the lower, or more negative the absolute magnitude, the more luminous the star. Therefore, you will see that the brightest stars appear at the top of the HR diagram, having the most negative value. Can you all see this diagonal line running across the HR diagram? This diagonal line is called the main sequence. An interesting thing you will notice is that most of the stars in the HR diagram form a diagonal line. More than 90% of all stars are main sequence stars. And in the main sequence, surface temperature increases as brightness increases.
Question 1. What is the lecture mainly about? Question 2. What is true about stars? Question 3. Listen to part of the lecture. Then answer the question. Why does the professor say this?
Have you ever seen iron or steel turning red when it is heated?
Question 4. How is the lecture organized? Question 5. What does the professor imply about the HR diagram? Question 6. In the lecture, the professor listed the characteristics of Class O stars and Class M stars. Indicate in the table below which of the following features of Class O stars and Class M stars are mentioned in the lecture. Click in the correct box for each phrase.